Good morning everyone, I am Mr. Ish. Thank you for watching. We have a good idea about how partial fractions decomposition helps us with regards to integrating a rational function of that type. You could probably do this in another way. I certainly would recommend the partial fraction technique because it's just so much easier. If you want to integrate this, that's the route ideally I would take. So let's integrate this. First, we will do the partial fractions determination. You're going to focus here on the denominator and you're going to factor it out. You can isolate an x squared here and then you'll have an x plus 1. Then we have this right here, x plus 1. But from this entire denominator, we can do factoring by grouping. And let's do that. We have an x minus 1 here and then we have an x plus 1 grouped out, factored out, and then we have x squared plus 1. Now the fact that we see these two items tells us in our template, the partial fraction template, we will have two items. One of these is a reduced linear factor. You can't factor it out anymore. But one is a non-reducible or an irreducible linear factor. That irreducible linear factor will have with it on top a expression bx plus c, rather than just b, but bx plus c, because it's an irreducible linear factor. Now that we've got this template set up, let's do the common denominator, and it's going to be x plus 1 and x squared plus 1. This fraction part here is not too hard. This goes in that x squared plus 1 times, so you have a times x squared plus 1. And then you have bx plus c multiplying with this x plus 1, right? If you want, you can very well erase this because you won't need this anymore. This denominator, you don't need it. You just have to open this up. You'll have an ax squared plus a plus bx squared plus bx plus cx plus c. All of this will equal this x minus 1. Since we're seeing squared components, you might as well bring 0x squared plus x minus 1. That completes the picture. Now look at all your quadratic terms, your square terms. You have an a plus b, and you're looking only at their coefficients. A plus b equals 0. That's one linear equation. You have a bx plus c, your linear items, bx plus cx is equal to 1, right here, the 1. And then you have your constants, a plus c is equal to minus 1. As you see, we can eliminate this x over here. It's redundant because we just need the linear term. If you're looking here at this equation, a is equal to minus b. So wherever you have a, you can plug in a minus b. I can put a minus b here. And then I have a minus 1. I can bring this down here so I can do a elimination. When I add this cancels out, this cancels out. C is equal to 0. 2c is equal to 0, c is equal to 0. If c is equal to 0, b is equal to 1. If b is equal to 1, a is equal to minus 1. Our terms are this in terms of the letters over there, minus 1, 1, and 0. And then when you plug them in right here, in places of their corresponding letters, it completes the picture. Minus 1, b is a 1, so it just makes the x into an x. The c disappears because it is a 0. That right there is my reduced version of this, but in terms of the partial fractions, it is the decomposed partial fraction. Now that decomposed partial fraction can be very easily integrated versus the parental rational function, which is hard to integrate. Hard for me at least. When you're integrating that, it's not hard. Separate them across the integrals, bring the minus out, you have a dx over x plus 1 plus x over x squared plus 1 dx. This here is very easy. You can just look at it and integrate it. You have minus natural log x plus 1 plus, if you do the polynomial substitution technique, u is equal to x squared plus 1, du is equal to 2x dx, and dx is equal to du over 2x. This divided by x will cancel out with this. You bring out a 1 over 2 outside, and then you'll have 1 over u du. When you integrate this, you'll have 1 over 2 ln u, right? ln u, but u was x squared plus 1. So we have everything here placed for our final answer, which I'll put for you right here in a very clean manner. The antiderivative of this rational function, as you see over here, is this, and we'll put it in a good proper order. 1 over 2 natural log x squared plus 1 minus natural log x plus 1 plus c. That right there is the antiderivative, and it looks good to me, and it should be right. So remember, this technique, partial fraction decomposition, is not very intimidating. You just have to be able to set up this good template by reading this appropriately and putting your factors on the top, and then from there everything goes very smoothly. Thank you for watching. Have a nice day.